Dear bald guy, I watched your threading videos. I spawned 100 threads to do my work, and my app got slower. You're a horrible person and you should feel bad. Hashtag enums matter. My name is Colt McAnlis, and yes, technically you can spawn hundreds of threads for your app, but as you guessed it, that might not be the best idea for performance. See, cramming too many threads into not enough CPUs is an old problem, and for decades now, thread scheduling has solved this by using various metrics to determine which thread gets the next slice of CPU time. Basically, every thread is assigned a priority. The scheduler then gives preference to threads that are more important, balancing that with the need to eventually get all of its work done. Now, priorities are assigned in a couple of ways. Firstly, Android assigns thread priority based on the lifecycle activity state of your app. Active and visible apps are assigned to the foreground group, where the rest are assigned to the background group. And threads in the foreground group get about 90 to 95% of total execution time for the device, where the background group only gets about 5 to 10%, which of course makes sense, right? I mean, visible applications on the screen should get more processor allocation than apps which aren't visible. Secondly, it's important to note that when a thread is created, by default, it's given the same priority and group memberships as the spawning thread. As such, it competes on equal terms for processor time allocation. So if your UI thread spawns 20 other high priority work threads, they will all compete equally for CPU resources, which pretty much ruins your chance of getting all of your UI work done in 16 milliseconds. To fix this, you should explicitly set thread priority for any threads you create in your application. This helps the system to schedule competing threads in the same control group. On Android, this is accomplished using the handy process.setThreadPriority API. Now, just to be confusing, this function takes an integer value between -20 and 20, where a lower value indicates a higher priority. Technically speaking, this number is actually supposed to represent how friendly this thread is with sharing its time, so negative numbers means it's more hostile to sharing its time, but whatever. To make this a little clearer, Android has provided some named values for you to work with. These values are defined by android.os.process and can be used as base states to work against. Default, of course, is what your threads are generally given. In addition to that, there's a couple quantized values to help you increment or decrement the priority to get a little bit more fine-grained control. For example, the UI thread is always assigned priority default, and any threads it spawned will also be given that same value. But in reality, worker threads should be lower priority, which you can set by adding priority default and priority less favorable. This way you can control which of your spawned threads might be more or less important than others. And in truth, setting these priorities yourself can be cumbersome. And that's why classes like async task or intent services do this on your behalf, so you don't have to deal with it. But if you're using threading and not using one of these fancy primitives, then of course you'll have to set priority yourself, so keep an eye out on that. Which is always the weird thing about performance. There's many ways to do one thing, which is why you should check out the rest of the Android Performance Patterns videos to get a better sense of all the options you have. And don't forget to join the Google+ community to ask questions to other great developers. So keep calm, profile your code, and always remember, perf matters.